Hello, good evening. Okay, good evening. Ay, from the what you guys choose to do wave, right? Okay, so we are going to do wave. I'm going to do revision wave to you. Okay. Um, Before I start, please like my channel. All right. Thank you for your support. Yeah. Got student PM me that can you cannot use the what my channel to ask me question. So I don't know what happened. Probably got something wrong. Later I go and check lah. But now it is too that one. Alright, too rush for me to know because I'm totally new to Telegram. I'm I don't know what should I edit ka or the group that I create. It is cross group ka. I don't know. So later I'm going to check lah. What happened? Why cannot PM in that group? All right. Um. Wait. Okay. Um. So let's start our that one. Okay. So wave. Alright. Fundamental wave. We look at web profile. Web profile. This is called web profile. This one. This one is called web profile. And then this one, right, when the web profile move, right, when move to left to right, up down or left right also can. All right. So when it move up down cannot, I'm sorry, up down cannot. Right, from left to right, from right to left, we call it as progressive wave. Right. Example of progressive wave, it is water wave. Right, when you drop the drop of water into the water surface, then it will propagate. When it propagate, so we call it as progressive wave, right? If the wave it is not moving, we call it a stationary wave lah, right? Example, guitar string, up and down, right? It go up and down. So this one is not so important because it all asks you in the objective only, all right? Okay, and right, if they ask you about this type of the wave, right, so you should choose longitudinal and transverse. All right, longitudinal and transverse. So how to memorize longitudinal? Longitudinal keyword it is parallel. All right, parallel only. All right, how to memorize? I'll tell you how to memorize later. And then transverse it is perpendicular. So the definition you should because I'm doing revision, so I'm not going to read it already. So now the longitudinal and transverse, the difference is long and trans. Right? Trans you got 90 degree. So 90 degree you see perpendicular. Alright, perpendicular. 90 degree transverse. Alright. Longitudinal only one example. Right? Somewhere. Memorize it because longitudinal and transverse they will ask you in the objective or structural 1 mark. Right, in SPM. So make sure you know longitudinal and transverse. Longitudinal, sound wave only, no others. Right. Okay. Now, right. Let me see. Okay. We got mechanical wave, right, and electromagnetic wave. Electromagnetic wave we are going to see in detail later. All right, mechanical wave is the wave that no need medium to propagate. No need medium to propagate. For example, water wave, sound wave. All right, you no need to. You need. Sorry, I'm sorry. You need a medium to propagate. Right, you need a medium like the medium like solid, liquid, gas, right, to propagate. But electromagnetic wave is you no need medium to propagate. For example, radio wave, infrared, microwave, visible light. So you no need medium to propagate. And then this one, electromagnetic wave, you will go in detail is it has a electric field and magnetic field. Right. So this is few important term that you need to know. All right, which is amplitude, period, frequency, wavelength, and speed. Right, and a lot of students, right, use this one as wave velocity, which is wrong. Don't use the word of velocity because this one velocity has direction. So when we talk about this one, we don't put the direction in. So you should not put what is velocity. So the formula is V is equal to F lambda. V is equal to F lambda. So I put this one bigger. Right. So V is equal to F lambda. And then this one few term here you need to memorize. Right. This is important. Right. You need to memorize. So I'm going to take one example enough. Right. I just simply take alright, simply take one. Alright, so this is this question got error. This question that I make on my own, so got error one. You see the amplitude I didn't put in the number. Alright, so then I do example number one. So example number one, right, this is called amplitude. Amplitude, memorize, right, understand it is the distance from the equilibrium point to the maximum displacement. So maximum displacement of the particle vibrate, right, from the equilibrium point. Is that okay? So now what do we have is this one is 5. But be careful when they ask you into this way. There is a boy with the float, right? I told you before, right, with the float on the water. Alright, so let's say the question asks about this. Alright, wow, the water wave, the water wave goes so high. Alright, alright, so this is 3 meter. Alright, so what is your amplitude? Or here, sorry, here, I'm sorry, I should put it harder. So here, let's say here to here, right, it is 6 meter. It is 6 meter. So when this one is 6 meter, mean you have to take half of it only, maximum displacement. All right, so that one will give you a 3 meter of amplitude. All right, this is amplitude. And then after that, what is period? Period is time taken to complete one complete oscillation. So from here to here, we got one complete oscillation. Right, make sure this is time. Make sure this is time, and make sure this is the unit that you use is second, or sometimes they'll give you in millisecond, microsecond. Double check it. All right, so this one how to do. Right, the period will be 1 over not 1 over time taken to complete one oscillation. It is 0.4, right? 0.4. You can see it here. 0.4 second. Time taken to complete one oscillation. Alright, frequency is equal to 1 over t. Alright, 1 over t. Alright, 1 over 0.4. 1 over 0.4, you get 2.5. The unit will be in hertz. Okay? I hope you are okay with here. Alright. I'm thinking of should I wrap it or not. Alright. because this one I didn't save another copy. Later if I accidentally save it, then everything will be gone, right? Never mind lah, never mind. Later I try to not to save it. If I click the button of save it, then I am GG. Okay. So a combination of this kind of question always asked in the exam, which is they will ask you, of course most of you will ask me, teacher, what is the difference between period and wavelength? All right, so period, it is about the time, right? Or millisecond or second, it is okay. And then this one, it is different, it is displacement or distance or displacement. This one are going to ask you lambda, this one are going to ask you period. So they ask you to find the speed, not velocity, speed. In case they ask you velocity, you are going to do the same, right? V is equal to F lambda, right? V is equal to F lambda. F is equal to 1 over T, right? 1 over T times lambda, right? 1 over T, T is 40 from here. You can see it's 40, right? 1 over 40, right? But this is milli. Milli is times 10 to the negative 3. This one you have to memorize, times 10 to the negative 3. And then lambda, wavelength. Wavelength, it is in meter. Same thing, you are going to take this one as 1 lambda, right? 1 lambda. So it is 10, right? Then you will get your answer as right, 40 exponent negative 3 times, oh okay, I forgot to inverse, equal, right? Inverse mean divide lah, times 10. Okay, so I get 250. Unit is meter per second, always 250 meter per second. Right, this is a few things that we're gonna have. And then the wave that they can give you in other kind of, they got many way to ask you. Sometimes they will give you the wavelength like that. All right, so this is the wavelength. Here it is a wavelength between the crest to crest, right? The crest to crest, it is called 1 lambda, right? 1 wavelength. So you need to know. So this is wavelength, you can find it. And then frequency, you can find it. V is equal to F lambda, you of course can find it. Right? If they ask you into this way, you need to know how many wavelength are there. Right? 1 wavelength, 2 wavelength, 3 wavelength. So this total 18, 3, 4, 5, 6, 6 wavelength is 18. So you can go get the frequency, right, of the water wave, right? Because they give you V is equal to F lambda. You can find it on your own, right? Now here, they can ask you into this way: compression, right? Compression to compression, or refraction to refraction. If wavelength, you want to talk about this wavelength, it is sound wave, right? Compression and refraction, it is about the sound wave, right? So wavelength also can be distance between 2 consecutive compression, or distance between 2 consecutive refraction, right, in the sound wave, right? After that, we are going to see, this one is in all syllabus, but they always connected in the question that they ask right now. All right, pitch is something control frequency. All right, high pitch, high frequency. Right, you need to know high pitch, then high frequency. Right, high pitch, high frequency, and low pitch, low frequency, of course. All right, amplitude is amplitude high mean loud. Amplitude high mean the sound will be loud. Right, if the amplitude low mean it is soft. And then sound, I am talking to you with audio sound. All right, audion sound is in between 20 to 20,000 hertz. If infrasound, it is low frequency, right? Less than 20 hertz, right? If ultrasound, it will be more than 20,000 hertz, all right? Ultrasound and infrasound, what is the use? We are going to see later. Okay, now basically it is the same, this kind of question. Okay, when paper 3, this, wait alright, I don't think paper 3 they will ask you into this question lah. Alright, wavelength. But anyhow, we try to discuss very fast, right? If I drop the water into the water surface, alright, one it is tuk 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 fast, this one is tuk 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 slow. So V is equal to F lambda. Alright, so speed of the water when it propagates, speed of the water it is the same. Alright, so this one is a constant. When frequency high, then we're gonna have lambda low. So you see the lambda here very low, lambda here very low, right? When frequency low, mean you drop the water tum 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 slower, right? So the distance between the lambda will be high, right? Of course, this is stroboscope. What is the use of stroboscope? Stroboscope is used to freeze the water wave, so that you can measure the wavelength. All right. If you want, but they very seldom ask you about this one, stroboscope. All right, because this one was removed already, right, from all syllabus. But I still put in 1 or 2 questions here lah. So I don't think it is important for you. All right. If you just want to know, it is frequency of the wave is number of slit times frequency of the stroboscope. That's all. Right. Okay. Let's say this is few step paper. We are going to pick up some to do it. All right. Okay. Which one? All right. Which one it is correct about the movement of the ball when it pass through the water surface, right? Water surface. Now understand, water surface is long or trans, right? Long or trans. Water surface is long or trans. Longitudinal wave or transverse wave? Longitudinal or transverse wave? Answer me. You can put your answer in the YouTube. Long or trans? Indirectly they will ask you this. Water wave, it is longitudinal wave or transverse wave? Answer me. Long or trans? Long or trans? Come on. Right? Long. Longitudinal only. Longitudinal wave only sound. No other. Right? So it will be a trans. Alright, we go back to here. Right? We go back to this. Okay. Where it is, never mind. Yeah. Okay, you see longitudinal fundamental wave, longitudinal and trans. Long and trans, right? Only example of long it is sound wave, no other. So water wave, other will be transverse wave, right? So it is a trans. It is a transverse wave. Transverse wave, up down, right? Up down. So answer will be D. Okay, now we try to see others. All right. See, this is the this year Malacca paper. All right. So now What is amplitude? Amplitude, here it go up, left, right, left, right, left, right, left, right. Right? So, in another word, so this is the equilibrium point, right? This is the equilibrium point, right? You can see here. This one is the equilibrium point. This one is the equilibrium point. So it come to here, and then it vibrate here, left, right, left, right. It oscillate here, right? So maximum displacement from the equilibrium point. This is the equilibrium point, maximum, right? So it is 3 mm, right? Maximum displacement, right? 3 mm. These two, it is correct. And then what is the wavelength? Wavelength is center to center, all right? The center. You see, when they draw, they put it to the center, right? So here to here, it is the center. So this is called lambda. Here it is called another lambda, right? 2 lambda is 120, right? Lambda is 60 cm. So answer will be A. All right. Okay. Now, we see next one. All right. When the amplitude of the wave increase, which physical quantity increase? Right. Amplitude increase. So amplitude is the wave amplitude increase. Right. Amplitude. So which one it is more? All right. So amplitude increase is nothing to do with period, nothing to do with frequency. All right. So V is equals to F lambda. All right. So lambda not increasing, frequency not increasing, so your speed will be not increasing. All right. The wavelength will be not increasing. So the only one thing that can happen is energy. So just now I did tell you, right? Amplitude. What am I doing? Amplitude is equals to loudness, louder, right? Loud or not. So when you louder mean you more energy, you shout louder. So more energy. So answer will be B. Okay. So we try to see this one. This one actually I have discussed to you last week already. But anyhow, because we are doing revision, so we are going to see it. Alright. What type of the wave? It is type. When they ask about the type. So type is only long or trans. Alright. So you need to read it properly. Alright. Diagram 1 shows a slinky spring that is demonstrate a type of the wave. You see here got mampatan, got compression, right? So here compression, here got a refraction, compression and refraction, right? What type? You compress and left right. So this one go type only got 2. So type only got 2. What is that? It will be long or trans. Right, you see, in the objective this year they ask you already, right? I mean not objective, in the structural question, right? They ask you already. Longitudinal, right? Longitudinal way, right? Now, complete the statement below by ticking the tick into the correct box, right? So at K, what is K? K is a refraction. K, it is a refraction, right? Next. All right. Circle 2 letter in the diagram 1 to present the wavelength. Circle, right? Wavelength is here to here, right? J to L, or you want refraction to refraction also can. Right, circle 1 only. All right, I mean circle a pair of number. Right, just take it a J to K. All right, next one. Give me one example of this one. No other example, just one example. I told you, don't give other. Just one example. What is that longitudinal wave? Answer. answer? What's the answer? Just one example only. Right? Remember this. Right? No choice. You have to remember. Right? Good. Sound. Yes, very good. Right, somewhere. Right, somewhere. Right? Good. Right? So we go quickly to damping. Damping and resonant. Damping is decreasing in amplitude, right, of oscillation because of loss of energy, right? So frequency, or we call it period, remain the same, meaning that I feel like want to go open the Zoom because I do this one very hard. My Zoom expired already. Wait, give me 1 minute. I go open the Zoom. Give me 1 minute. Wait, I get used to use Zoom already so that I can no need to that one. Okay. Can you hear me? Can you hear me? Because I didn't turn on the sound. Can you hear me? Can hear? Sound should be no problem, huh? Okay, good. Alright, no. Alright, so this one I feel more comfortable. Alright. Alright. Okay. Now what we have is okay, damping, decreasing in amplitude, where your amplitude here and here and here decreasing. So if the question asks you about this one, it is talk about this way, right? This one they put it as amplitude, then it had to be like that. Okay, it have to be like that. This one is wrong. This graph is wrong. Why? Because this time the period here not decreasing, right? So the period must be the same. Right? I'm not drawing so well this one, but anyhow it is the same. Anyhow it is the same. Period or frequency will be the same. All right. And damping, we can divide it to two types of damping. It is internal damping and external damping. External because of the frictional force, right? Because of the friction. Internal damping because of the compression of the molecule itself, like stretching, compress. Right? So this one is not so important, right? Also, right? So you just need to know one thing, right? Which is period remain the same, right? And objective, it will give you one question probably, right? Now, the next one, it is resonant, right? This one got chance to come out in 4-mark question, right? 4-mark question. Explain what is resonant, all right? Resonant, the thing that you have to do is two things, right? Here, natural frequency and maximum amplitude, right? Now, when the X oscillate, this X oscillate, D with the same length, right? So that it will vibrate with maximum amplitude or oscillate with maximum amplitude. Because of natural frequency, I want to see the word of natural frequency, 1 mark. And then natural frequency, same, 1 mark already, and then it will vibrate with maximum amplitude, another mark. Alright, so other than they will ask you what is this, this is resonant, 3 mark, 3 mark. Right? And the length, it is the same, 4 mark. Right? Not much mark, not many mark to ask you. Alright, so it probably can come out in the question this way, right? Okay, now this is one few example of the resonance happen in daily life. So we can see here a group of soldier here, right? A group of soldier here, marching on the bridge and asked to break their step very often. Left, kiri kanan, kiri kanan, kiri. Alright, along the bridge, kiri kanan, kiri. Alright, and then when their marching frequency, their step, kiri kanan kiri, same as the natural frequency of the bridge, so it produce a maximum amplitude. Your natural frequency, same, then it will give you a maximum vibration. Right? So this one is one of the example happened in Tacoma Bridge. It collapsed because of the soldier there marching only can kill the bridge, right? Can make the bridge collapse. Right? You see how big is the force, right? So this is one example. It came out in the stat paper before. Alright, so radio wave, oven also. Alright, Alright, radio wave and oven. You unless you want to ask me, like, if not, then you can just memorize it is radio or microwave, right? Soprano singer, when I sing, the glass vibrate, right, with maximum amplitude. When my sound pitch, same frequency of the glass, the wine's glass, that the glass will vibrate with maximum amplitude, right? Now, okay, so we are going to see some question. This question quite blur here, but anyhow, we just take it lah. Which of the following is a benefit of resonance in daily life? Right. So this one is yes. Right. This is the answer. Right. Radio wave. Right. This one is ultrasound. This one is resonant, but not benefit. This one not benefit. Right. This one is refraction. Right, hologram. This one I did do it with you last when I do revision. We do it before, right? We do it before, hologram on the bank card, right? The transparent thingy. Okay. Okay. The which graph shows the correct relationship between the time for the oscillation system, right? Okay, you see, when I got a resonance system, not resonant, oscillating system, here before I put it, right, put it into the water, right? So here I put it lower. This is the water. Now what I do is here. So what I do is I route this one, right, the swing. Okay, here. Now if the lot that I put it into here and then I put it down, right, then it will start to when it touch the water, it get faster or slower. Once I touch the water, it getting faster or slower. Right, at first it is amplitude bigger, and then touch the water. Something stopped it, right? Something stopped it. So the amplitude getting more or less because we got friction. Water friction. Not water friction, just friction. Right. So the amplitude getting lesser. This one is correct. This one is wrong. Right? This one amplitude cannot getting more. No. This one amplitude getting lesser and lesser. Right? A or D. The problem is A or D. A or D. The problem is What do you think, A or D? So now the thing that you want to see is, now this is called damping already. You need to see this. You need to check this one out. You need to check this one out. So A or D, what do you think? A or D? So they will ask you indirectly. You see, they never mention, oh, this is damping. Which one is correct? They will not ask you that way. So they will ask you another way. This one is ahang pepper. This here. Some of you have did it. Answer? A or D? I give you two choice only. A or D? Answer? 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 Hello? Answer? A, right? A, right? Why A? Because during damping, the frequency have to be remain. Frequency must be the same. During the damping, frequency must be the same. Now see, this damping is very popular asked in the objective question. Alright, so the which answer is correct about the damping? So damping decreasing in amplitude. In this one, the frequency, sorry, not frequency, the amplitude remain the same. No, amplitude remain the same, no chance. This one, yes, amplitude decreasing. Amplitude decreasing. So answer will be C. Right? Because this one, the period remain the same. Right? The period here remain the same. Period here remain the same. Right? This one period, no. The period not remaining. Okay. We try because that is many also. I try one only. All right. I'll try this one. I'll try this one. This one. Okay. 5.1 shows the 4 pendulum bob with different length tied to the string. All right. What is the meaning of amplitude? Amplitude is maximum displacement. Right. Maximum displacement of the particle vibrate from the equilibrium point. Right. Maximum of the particle vibrate from the equilibrium point. Right. Is that okay? Maximum displacement of the particle vibrate from its equilibrium point. Right. Is that okay? You can go and memorize that. You can go and check your textbook. Right. They give you this definition. Right. Which pendulum oscillate with maximum amplitude? Right. The question is not so good. Right. They said which pendulum oscillate with maximum amplitude? What's the answer? This question is not good, but we know what do they want to ask. What is the answer? Which pendulum will oscillate with maximum amplitude? Answer? Which one will oscillate with maximum amplitude? X or A or sorry? A, B, C. X or A or B or C? Come on, answer me. Answer me. Okay. Yeah. Answer is B, right? Why? Why? Now, if I answer alright. So I said why not X? You swing the X, X will vibrate with maximum amplitude, right? Why not X? But they should say, right? That's why I said the question is not good, right? Which pendulum will force to oscillate with maximum amplitude, like that. Baru betul. Alright, which one it is forced to oscillate with maximum amplitude? Question, this kind of question sounds better, right? I mean, right? So you will not choose X already, right? Right? So which pendulum oscillate maximum X lah, because you go and swing it how can we not be maximum amplitude? But anyhow, we know what do they want, right? So what do they want is this one among A and B and C. Alright, so give me one reason. Because, alright, 1 mark only. Alright, because keyword. Now all the thing that you need is just keyword. What's the keyword? B has the cannot be C. C is longer. No. Okay, you swing X swing, and then X oscillate, then A, B, C will force to oscillate. B will force to oscillate with maximum amplitude. Why? Because I want keyword. Keyword is, yes, very good. B has the same natural frequency of X. Or if you don't want to tell it into this way, you put it in a very, very normal word is, because the length of the pendulum B same as X, will be okay. This one will be okay, acceptable. Alright. Then this phenomena is called damping. Alright, calculate the period of X. Alright, here, period of X. Period F is equal to 1 over T. So we know that F is equal to 1 over T. F is equal to 1 over T. F is equal to 1 over T. F, 2 hertz. Period, I don't know. Period is 1 divided 2, 0. Sorry. Yeah lah, resonant. Yeah. What am I thinking? Resonant. Yeah, resonant. Yeah, resonant. Yes. Yeah, you're right. Resonant. Resonant. Yeah. Thank you, Melvin. 0.5. 0.5. You need second. Resonant, not damping. Right. I keep on thinking of this one is going to get slow. Okay. Diagram 5.2 shows jambatan Gunung Tacoma, right, in America, right, was collapsed in 1940 due to the C, right, C, resonant, right, C. Based on the phenomena, right, explain how this tragedy happened. Alright, so the keyword you must in, right? What is the keyword? They've got 2 mark only. Natural frequency of the bridge same as the frequency produced by the matching frequency, matching from the soldier lah. The first keyword is natural frequency. You got the natural frequency already. Good. Right, and then the bridge will force to oscillate with keyword maximum amplitude. Right, the bridge will force to oscillate with maximum amplitude. This two mark. And finally, collapse. Keyword must be in natural frequency and maximum amplitude. Now next one. Next one. Pendulum X will stop oscillating after few minutes. Right, after 5.3, on the 5.3 sketch displacement time graph. Right, it will stop oscillating. This one is they are asking you about the damping. 2 mark. Right, 2 mark. So what you need to do is up, down, right, and then up, down. Right, you see this one I am drawing not drawing well. Why? Because you see this one big and then this one getting smaller, so I should have the same one. Right, so when you draw, make sure it is the same. Okay, make sure this length here, same as the length of here, same as here, same as here, same as here, same as here. Okay, alright, make sure it is the same. 1 mark. And then the amplitude decrease, 1 more mark. Alright, 2 mark. Normally lah. Okay, we go quickly to what is wavefront. Wavefront is an imaginary line or plane that vibrate every point on it in phase and same displacement from the source of the wave. And what does that mean? Right, here this is wavefront. You got wavefront, you got few wavefront. Wavefront, it is the crest. And crest. Right, so this is called wavefront. Right, this line, it is called wavefront. This is another wavefront. This is another wavefront. Right, so now this is wavefront. This is wavefront. Right, wavefront. So when we use the light to shine on the water surface, then you'll see that is bright fringes right here, bright. So this one, not mistaken, quite long time ago there is one question I asked in SPM, right, how to draw this. So you agak need to know how to draw. Right, the line come into here, the light ray come into here. So this is called tangent, this is called normal. The light will not go into straight, right? It will not go into straight. It will be reflected from less than A to the water, so it will bend toward the normal. That's why it come into here. Here tangent, here normal. The angle will be lesser, so the reflection will be lesser. It will come to here. So all the light will be focused into this point to produce a bright fringe here. Mhm. Okay. So you will produce a bright and dark fringes. Okay. Um. Now, after we know what is reflection, right? In light we are going to do more detail, but this one we just agak-agak. This one agak-agak lah. No need to go in detail, right? Because light talk more detail on the reflection. So the anchor of incident and reflection always same, right? Wavelength no change, frequency no change, no matter what, frequency will never change, right? Unless you change it. Unless you change it, mean this one, cikgu just now you said the water drop one drop by one drop the frequency change. Yes. This one, the frequency change, yes, you go and change it. But this one is saying that if the wave it come to here, from here, after it hit the surface, right, frequency will change or not? Frequency will not change, right? Because you hit the water right now, boom, 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 right? Boom, 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 right? Then it will reflect boom, boom, boom this way, right? The frequency no change. If you change it, boom, 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 you hit the water faster and slower, and then faster and slower. Then this one will be faster and slower. Also no change. But we normally will not do it. What for you do it? You change the frequency at here, right? But the frequency after the reflection, it will no change, right? Mean you fast, then this one fast. This one slow, then you hit slow, then it will come slow, right? So frequency will never change. Speed, don't say velocity, say speed, right? No change, right? Speed will affected by that. We are going to see reflection later. It will affected by that. Okay, it will affected by that. And then direction, right? Change. It will change the direction. So the left come to here, become right. Right? So this one is called law of refraction. Law of reflection. Law of reflection. Law of reflection said that I is equals to R. Right? I is equals to R. Incident angle is equals to reflected angle. Okay. Okay. Now how to draw? Alright, this is how are you going to draw. So what is this one? This one is wavefront. So the light come into here. When you come into here, so you need to draw one tangent and one normal, right? One normal line. After you draw, then you need to draw the reflected ray. This is called direction of propagation, the arrow here, right? This is how you get it, right? The angle. So if the angle is wider, this angle will be wider also, because incident angle is equal to reflected angle. Incident angle bigger, reflected angle also bigger. Okay. Now you need to learn how to draw, right? Even the shape is different, right? You need to learn how to draw, right? Now, I don't want to use three guy running here. If you want, then you use lah, right? One. But I think it is easier if I use it, right? But anyhow, it will be okay, right? Okay. I takut when I use three guy running, some of you never learn my attend my class before, then you don't know what am I talking about, right? So never mind lah. Alright, I try to use it. Yeah, this one come to here, this one come to here, right? One guy A, you got A, and then B, and then C, right? When the guy A, the guy A move to here, hard to for me to draw. Right, the guy A move to here already. Guy A move to here, then B also move to here, C also move to here. A move to here, B move to here, C move to here. A move to here, B move to here, C move to here. Right? C move to here. So what we have is A is here, A is at here already, B is at here, and then C is at here. Then B hit the surface. B, because it moved further faster, right? So it come here. Then A still going forward. C still have balloon sampai. But once B hit the surface, it start to reflect already. Right? It go back already. It go back already. It hit the surface, it go back already. In this position probably. Then A baru reach. C baru reach. It baru hit the surface. And then when B come to here already, then A baru here and C baru here. Right? So you can connect the line, these three guys together come into this way. Right? Like that. Right? That's how you get it. Right? Am I right? Okay? And when you got curve, you need to know this one, it is come into this way. This one is come into this way, right? And then you got a circle at here, I told you before, right? So this one, it is a focal length, focal point. So you need to put in a focal point, right? You need to put in a focal point at here, right? If you use the way of drawing this way. Now, if you don't want, right? So reflection, the light come into here, right? Come into here. So you need to draw something that is 90 degree here first, right? 90 degree here first, right? So after the reflection, right? After the reflection, so reflect bar, right? So this is tangent. This is normal. What am I doing today? So this one will be the incident angle. This one will be reflected angle. Same thing of this one. This is your normal line. This is incident angle. This one is your reflected angle. So you connect this point to this point, reflected. Now, this one is your dotted line. This one is your dotted line. You call this one as focal point. Same thing. You get back to the same thing. Am I right? Right. They probably ask you this. Right. So you need to know how to draw it. Right. Need to know how to draw it. Right. Okay. So I want to take one example. Right. 15. Right. Example number 15. A boy clapped his hand once in a room and heard the echo twice. Find the time interval between the two echo. So here it is a wall. Here it is a wall. This question got error. I said my question. I never said how far is this room. You see, I set my own question, then got mistake, right? Let's say this is 100 meter. This room, it is 100 meter, right? This room is 100 meter. I haven't checked. Oh, that's why I not there to send the notes to you. I type this and then, yes, correct. Very good. Right? I give you this question. Right? You guys try to do. Right? A guy stand in the room, and then heard the echo twice, right? And then the guy, it is at this position, right? This position, which is it is going to be nearer to one side and then further from the other side. So this one will be, let's say, 25 meter. This one will be, I don't know. But he heard twice. Find the time interval between two echoes, right? Find the time between two echoes, right? Find for me. Let me calculate first. Come on. Anyone? Sharizan, your formula got something wrong. Okay. D is VT over 2. Correct. Your formula is okay. Okay. What's your answer? What's the answer? You can answer in the pool there. You can answer in the pool there. Let's say the boy, it is 25 meter here, and then this one I don't know, but the room, it is between the two wall, it is 100 meter. Some of you start the answer already. One vote already. How about others? Do it right now. The formula given is V is equals to 2D over T. Sorry, just now I said your formula wrong because I seldom use the D is equals to VT over 2. I very seldom. I don't get used to it. That's why, why got then if I time it up, it should be the same. Right? Because velocity is distance over time, right? Come on, do it. Only two what? How about other sleeping? Sleeping. How's come on? How is it? How about others? I'm waiting for you. I'm waiting for you. A boy cracked his hand in a room and then he heard twice. Echo. Echo twice. Find the time interval between two echoes. Time interval mean selang masa. The time in between two echo. The first echo how long? Second echo how long? Right? The difference in between the two echoes. Three minutes already. Only three of you doing 0.66. Okay. Alright, so I am going to do it. Alright, so here I want to see first echo how long time it takes. Because this is shorter, right? Velocity, it is 330. 2d, d distance is 25. 2 times of distance time t. So I want to call this t1. Right? The echo 1 it is, right? Echo 1 it is, echo 1 it is 330 divide down, so I got 50. 2 times 50, 2 times 25 is 50, and then divided by 330. So the first echo will take me 0.15 second. 0.15 second. So this one is going to take me 0.15 second. So now this echo come to here. This sound, not this echo, this sound. This sound come to here and then start to reflect. This one further distance, so it will probably take longer time. So velocity is equals to 2d over t. Right? It is t2. I call it the second time. Right? The second time. Velocity is 330. It is 2d. D it is, distance it is 75. Right? 100 minus 25, it is 75. Over the t2. T2 will be 330. Right? Sorry. It is 2 times 75 divided by 330. Divide by 300. 4.45 second. 0.45 second. 0.45 second. Ayo, no answer. 0.45 second. Do I do anything wrong? Yeah, correct. I just no answer. Because I just that one. Oh, so time interval is t2 minus t1. It is 0.45 second minus 0.15 second. Right. 0.15 second. So answer is 0.3 seconds. So best answer will be 33 seconds. 哎呀， The best answer will be 0.3 second. I should prepare the pool for you, but anyhow, my answer is there is all wrong. That one is should be 0.33 second, right? D, but I put to 33 second there, right? Okay. Right, answer is 0.3 second. Right, time interval is 0.3 second. Do you understand it? Do you understand it? But, right, I got one very, very tricky question here. Right here. Now, I want you to try to do example number 16 here. Right, which is, now I read, a boy shout in front of two microphones that is 20 meter apart and fit into the cathode ray oscilloscope. Alright, two peaks appear on the CRO. Find the speed of the sound. This one I don't want to give the number. Right? You go and find for me. This one is tricky question. You try to do it within 5 minutes. I help you for the first part, okay? Here we got the X gain 3 millisecond. I help you 3 millisecond. Here, how long it is? It is 15 cm. Alright, so one, you see my question got something wrong. You see, that's why I'm not there to send to you. This is 3 millisecond per cm. 3 millisecond per cm X gain. Alright, 3 millisecond per cm. So the time taken is, you got 15 cm, right? Right, 1 cm is 3 millisecond. 1 cm is 3 millisecond. 1 cm is equivalent to 3 millisecond. So 15 cm, the peak and peak. 15 cm is equivalent to how long time it is. The time I don't know, so I can cross multiply it. It is T is equals to 3 millisecond times 15 cm. This is per cm, so that your cm can be cancelled. 3 times 15, right? 3 times 15, you will get it as 45 millisecond. 45 millisecond. So this, not millisecond, millisecond. So this CRO, it is going to give me 45 millisecond of time, meaning that the thing travel from here to here, it is 45 millisecond. So I help you for the first part, and then other you do it for me. 45 millisecond. What's the answer? the boy is shouting at here. Hello. Alright, then come to here. This is the you keep on doing it first. I give you 5 minutes. Come on. I already helped you the time. Find the speed of the sound. I'm waiting for your answer. Later I spend about 20 minutes to answer your question. You got question, you can PM me in WhatsApp or in Telegram. In Telegram, right? The group, the WhatsApp group, what's that called? The Telegram the group that I created cannot be PM, cannot send message. Some of you tell me, but never mind. You PM me, then I will answer your question. If you got other question that you want to ask, right, I'll do it for you. I'll do it for you. Some of you already PM me one question, then I'll explain to you why. Hey, no one answering me. Hello. I'm waiting for your answer. Come on. Not there to answer me. Okay. So I have spent 5 minutes. None of you answering me. So now I'm gonna answer this. I'm gonna answer this. So velocity is equals to distance over time. Alright. Velocity is equals to distance over time. Right? Your distance is 20. Time it is 45. Times 10 to the negative 3. That's all. 20 divided by 45 exponent negative 3. divide by 45 exponent negative 3 equal E. 20 divide by 45 exponent negative 3. 444. Right? 444. Is that okay? 444. Of course, you ask me. Surely, I believe you ask me. Teacher, isn't it D is equal to 2D over T? Yeah lah, huh? Why I don't use 2D over T, I use D over T instead? Because 2D over T only do for reflection. This one is not reflection. When you shout to the microphone, the sound pass through here. Alright? Pass through here, then you got the first peak. And then the sound pass again, come to here, come to here, come to here. So this is a velocity that it travel from the microphone 1 to microphone 2. The microphone 2 has a smaller amplitude. Why? Later, this is why. But anyhow, it has a smaller amplitude. It receives smaller amplitude. Right? Do it reflect back? No. Then why you are going to use 2D over T? You are not going to use 2D over T, right, in this case. You understand what I'm saying here? So be very, very careful. Now, so velocity, I got velocity is 20. Velocity, I don't know. They asked me to find. Speed, they asked me to find. Then 20 is distance. Over the time, I got it from here. Right? So I got 444.4 ms minus 1. Is that okay? Question? Now, why the amplitude here it is smaller than here? Right? Why? My question is, why? Why the mic 2, the peak in the mic 2, it is smaller than mic 1? Why the peak in the mic 2, right here, mic 2 smaller than mic 1? You can have many answers. Why the amplitude in mic 2 it is smaller than mic 1? Answer me. I'm still waiting for your answer. I'm still waiting for your answer. Anyone help me? Okay. Any other answer? Longer distance than mic 1. Okay, good. This one is acceptable. This one is correct. Any other answer? This one is correct. Any other answer? Sound is coming into this way, right? The spreading of the sound. Right? No other answering me. Okay, I end the Q&A. Here. Why? Why? Because damping of air, not damping of air. Right? Not, this is not called damping. Damping happen. This is not called damping, right? Because you are very near to the microphone, right? When you shout to the microphone, right? You got another microphone which is further. So the distance is long. The sound is spread away. When it spread, the energy loss, right? The spreading of the wave, because of this one is called diffraction, right? Spreading of the wave. It will spread into this way, right? It hit the obstacle one or what, so it will go. So it will go into this way. So the sound that received from here must be lesser because the sound spread. This one, the block not so significant. I don't want to call it as diffraction. But I call the sound spread, right? The sound spread away, so the amplitude, the energy reach the microphone 2 will be lesser. Or some of you answer because it is further. Yes, correct. Further, so that the sound reach there, energy less there, or already some of them are lost. Energy loss. Then you can answer me. Longer distance or energy loss or the sound spread. Okay. Now, okay. Now, when you do to this one, all right, application of reflection in daily life, all right, you can have velocity is 2d over t, right? You can use to calculate the depth of the seabed, all right? You can calculate, you can see where is a lot of fish, right? You can see, check where got a lot of fish, right, by using this way, right? So when you do to this kind of question must be, 2d over t. V is 2d over t. Okay. Or ultrasound is used in the medical field to examine the fetus or internal organ. Why? Because ultrasound is not high penetrating power compared to X-ray, right? Or you can say, if you don't want to say penetrating power, you say not so harmful, not harmful compared to X-ray. X-ray is more powerful. Or sometimes they will ask you, all right, why? All right, so ultrasound is not killing cell, right? Ultrasound will not kill cell. All right, you can answer into this way, right? And then here, ultrasound produce. If they ask you to compare ultrasound with X-ray, ultrasound produce a better image compared to X-ray. For this, now I need to slightly explain to you why. Why the X-ray it should be better, but it can go in deeper, but because of the X-ray when you go into mother uterus here, the penetrating too high until it hit the body tissue, then it still can go through. So what can you see? You can see the bone only. X-ray, what does it use? It will block by heavy metal, calcium. Baby's metal, baby's body got calcium good got calcium a lot. No, I mean you want to see the body of the baby, right? You want to see the body of the fetus. You don't want to see the bone of the baby. What for? What for, right? So ultrasound will produce a better image compared to X-ray. X-ray is used to see bone, not to see the baby one, right? You understand what am I saying here? You get what I mean here? So that's why we are using ultrasound. Is that okay? The ultrasound, the penetrating power is low. It hit until here, then it hit skin, then it start to reflect already. We can calculate, right? It hit here and then reflect already. Because the ultrasound, the penetrating power not high. Is that okay? Very good. Right? I hope you understand. Second one, right? This one, reflection. I'm not going to do this one. All right. So ultrasound is used to remove the kidney stone. This one I want to explain. Right? Cook the food in the mic. I want to cook the. I want to explain this one. I want to explain this one. Right? So here, right? Either this one or this one. I choose one to explain. Right? Same. This is the same resonance. I read first. Right? The frequency of the microwave is same as the natural frequency of the water molecule and fats. And then the water molecule and fats is forced to vibrate with maximum amplitude to produce heat. The heat produced can cook the food, right? Resonant. Now this is your chicken you want to cook tonight. Here got a lot of molecule. This is called water molecule or blood, right? Blood vessel, blood, water, right? The blood content of water. So when this is your microwave oven, you produce one wave, right? This wave got one frequency, right? Water got one frequency. If not mistaken, water's frequency it is 2 times 10 about 10 to 11 like that hertz. And June, the frequency of the oven, right? Frequency of the microwave, right? Same frequency of this. Then what happened? The molecule here is forced to vibrate with maximum amplitude. Vibration of the molecule, vibration of the particle will produce heat. Then this thing it is going to heat up because of resonance. So the molecule, the water molecule or fats molecule is forced to vibrate with maximum amplitude because the natural frequency of the water molecule same as the frequency of the microwave. This is resonant. This one is resonant, right? This one is resonant. This one is not resonant. Hey, this one is not resonant. You want to shoot one wave to the baby and then the baby vibrate. No, this is not resonant. This is not resonant, right? This is reflection, right? Reflection. This is reflection. You want to see the baby's image. The other one it is you want to see you don't want to see, sorry, you want to cook the food, so it is resonant, right? Ultraviolet ultrasound also produce other use, right? You can remove the plaque of the teeth or kidney stone, right? Also resonant. Right, we try to do some question, right? As I promised you, you can ask some question. PM me in the group. PM me in the group. If not PM me in the group. PM me the question right now. If you got any, PM me. Alright, Telegram, WhatsApp, any. Alright, I will answer your question. Okay, we do some stat paper. Which of the following statement refer to the longitudinal? I don't want to do this. Long, I don't want. Alright. This one you see my arrangement. I have to. I'm now checking. Checking the notes. I'm I'm compiling the notes. I still need time. Alright. This one I still think I'm not doing so well. Right. I mean I don't arrange the notes well. That's why I'm not there to send to you. 我不敢 send 给你们. Alright, we do 14. This one I should put it at the front there. Alright, this one, the phenomena that involved in this is you shoot here and then what is this? This is called reflection or refraction. Refraction it is how deep it is. Diffraction is you hit something and block, and then you still can go through. Right? So this one is called reflection. Refraction. Alright, number 16. We do number 16 here. This is Pahang paper 1. So which comparison it is correct about the reflection of sound wave that is incident sound wave, right? Reflected to the wall. Okay, now first one, the speed of the incident and the reflected it is the same. Yes, speed and the reflected it is the same. Right? So frequency of the incident is less than. This is wrong. This one is wrong. Must be the same. Right? The angle of incident is greater than angle reflection. No, must be the same. Law of reflection. And then lastly, the wavelength of the incident is shorter than the reflected. No, right? No, it is the same. At wavelength, no change. So answer will be A. You see, this one I should put it at front also. Oh, I want to do a remark first. Give me 1 minute. I want to do remark. Okay. And next one. Which of the following characteristic change when the wave are reflected? Why I all put to here? I should put at the front. Yeah. Which of the thing change here? Which one change? Right? So which of the following characteristic change? Answer? Answer? A, B, C, D. Answer? Answer? Good. Direction change. Alright. Wavelength? No change. Frequency? No change. This one you must memorize, right? Because they frequently ask. Right? We do one question 15. Right? You do one question 15 for me. Right? Question 15. What's your answer? Calculate for me. V is 2D over T. Calculate for me. I want to see you guys can do it or not. Alright? Put your answer in the YouTube pool there. Number 15. Question 15 here. Got some of you put A, some of you put B. But I cannot see who is putting A or B. Cannot. Other? Put your answer. Right? You can put your answer there. Alright. You should. Sometimes you show the answer already. Other people will copy your answer. Right? B is equal to 2D over T. Right? Right? I end the pool already. Right now. I end the pool. Alright. V is 1500. Is 2 times D over the time. Time taken is 0.36. 0.36. Right? This one go up, then go down. D is 1500 times 1500 times 1500 times 0.36 divided by 2. You will get 270. Yeah, you are right. Yeah, right. B. My answer is B. Right. Okay. So I said I will do some question answering here. So PM me your question. Alright, got one only. So far got one only. So I'll answer your question. Here. From Iswari. Okay. Okay. And this one. This is a question asked. Alright. Can you see it? Any question that you want to ask me, not wave, not necessarily must be wave, right? Can it other question that you think you want to ask me, then I can answer for you. And this is the question. So all right. So I read the question first. I read in English, better, right? The stopping potential. So stopping potential mean it want to stop the potential to stop the charge. The start is from here, and then it want to move to here, move to the negative terminal. All right, from positive terminal want to move to the negative terminal. So it want to stop it. All right, what is the kinetic energy given to the electron by the incident light as shown in the diagram 26, right? So first of all, now you're gonna have the formula of, now we talk about energy, kinetic energy. The formula energy is equals to half mv squared, right? I have done this question for her, but for you, but never mind. I purposely do some revision, so I want to find it. So I must have mass of the electron, which is I don't have it here, and then velocity, which is I don't have it here. I cannot do it, so I cannot do anything from here. So energy, kinetic energy, I cannot already. So the only thing that I can have is here 4 volt. So what do I do is, now I know that is a formula of energy is equal to EV, but a lot of you don't understand why. Why, teacher? Energy is equal to EV. If I give you directly, I feel like you cannot understand. So what I do is I use voltage. What is potential difference? Potential difference is work done to carry a unit of charge. Do you agree? What is potential difference? Potential difference is a work done to carry a unit of charge. Right? Potential difference, I got it, 4. Right? W. Q. Charge. Charge is electron charge. What charge? Electron. How much is this? 1.6. But you see the answer, they never give you in column, right? In joule. No, they give you in EV, right? So I just put it, time it up here. 4 times E. Electron is your work done. For what? For what? For what? For what? For what? Unit. 4 volt. So that's why we got 4 EV. Work done, we got 4 EV. If you want to change it to what's it called? Joe, this question not asking me, but I want. The answer is B already, but I want to change it to Joe. So 4 times electron, you don't put the negative in, right? I don't know why do they put in. They put in the negative because of that one is the electron only, right? Electron has a negative charge, but when we talk about charge, we don't energy. We still put in energy, or you got negative. You will not put in negative, right? 1.6 times 10 to the negative 19. This word no need. This word belong to here. So, if the answer asking me, the question asking me about this, it is 4 times 1.6 exponent negative 19 equivalent to 6.4 negative 19, right? 6.4 times 10 to the negative 19 unit in joule. This is the answer. Now, any question that you want to ask, you can ask me here. Any question? If no question, then I'm going to pick up some question from the physiotherapy group. Okay, I go pick up some question there lah. All right, the latest one. Okay, this is the question. Okay. Diagram 11 shows the image formed by the screen. It is blur, right? Blur. Which modification can produce a sharp image on the screen, right? You want to, why it is blur? Because the image format here. The image is format here. The image is format here. You put the screen at this position, how can it be clear? So of course it is blur. The image is format here, right? So now we look at A. O in BM. Oh no. Yeah. Replace the lens with the focal length, which is longer focal length. Right? When the focal length is longer, alright, what gonna happen? Right? We see other first. Alright, B. Replace the lens with the other convex lens with shorter focal length, or move the object further from the lens. Move the object until it's at the focal point of the lens. Or B, C and D definitely wrong already. So you want to move, you cannot move further away from the wait. Move the object, they said move the object, or not move the screen. Move the object. If you move the object further from the screen, your image form will be nearer. So wrong. This one is wrong. Totally wrong. Right? If you note it, 1 over F is equal to 1 over V. Not enough space. This picture is too big. I cannot have any space to do. Alright. 1 over f plus 1 over f plus 1 over u, right? Right? If now you put your f, let's say it is 10 lah, all right? I put it as 10. Your v, I don't know, right? Your u, at first it is, let's say it is 20, all right? Let's say 20, yeah, all right? So 10 inverse minus 20 inverse equal v, you will get I don't need to calculate, should be 20, right? You calculate, it will be 20, right? So if you move your object further from the lens, all right, 1 over f still the same, 1 over v plus 1 over 30. V you will get lesser than 20 because you move further. It must be lesser. So I calculate this one, 10 inverse minus 30 inverse equal, and then inverse equal. So I must get less than 20. So because of you move further. So this one is totally out already. Move the object away from the lens, it is out. Right? Move the object until it at the focal point. Right? You move this one at the focal point, no use, right? No use. Because the image will not form at the focal point. Right? I mean, move the object to focal point. If move to the focal point at here, if this one is a focal point, you will not get a sharp image. Because this one, if at the focal point, you will get the image from the infinity. So this one out. These two out already. Yeah? Alright, so now what do I want is, now replace the length with the focal length with the longer focal length. So now when f, if I want this one, I write out this one. If your focal length longer, what gonna happen? I cut this one easier. If 1 over f is equal to 1 over v plus 1 over u, I said replace with the longer focal length. So 1 over 20 is equal, not 20. 1 over 15. Right? I put longer focal length, longer. I want to see what happened. Object never change. I want to see what happened. Right? So now I calculate 15 inverse minus 20 inverse. 15 inverse minus 20 inverse equal. At first, your image will be formed at 20 here, 20. Now your image will form at I calculate it will be formed at 60. So your image can form on the screen or not? Can right now. So the answer will be replace the new lens with another convex focal length with longer focal length. Why? Because the image will form at further distance. So answer will be A. Do you understand it? Do you understand it? Is that okay? Any other question? Any other question? So I pick up one more question before I end the class. If you got question, you PM me because the group cannot work yet. I don't know what happened. I pick up one more question. I don't want to post it in that group because this one too ugly. This one very hard to explain, right? You have to join my YouTube to explain. If I explain to you, because of when the focal length increase, the image length also increase. Now this one kind of hard to explain, so I'm not going to explain. Right? Wait. Okay, this kind of question, right? Okay. A trolley X of the mass m traveling at a constant speed of collide constant speed and collide head on to the head on. Head on very important. This word. Head on. Head on. With a stationary trolley Y with a mass 2. Right? The two trolley, I don't know why. I don't know why stationary trolley is still want to say head on. If head on, normally it is not stationary, right? Because if stationary head on or not head on, it is okay. But anyhow, with the stationary trolley Y, mass 2, the two trolley move together after the collision. And then it is recording by the running tag of the frequency 100 Hertz. The frequency is 100 Hertz. A portion of the tag is shown. Find the ratio of mass 1 to M2. Right? This is M1. This is M2. And then let me read one more time. Velocity x is recorded by the tag. True. PQ 10 cm. PQ here is 10 cm. RS is 5 cm. Right? This is all the information that I have. Right? And then they move together. So what do we have is this one is normally, you see why it is suddenly slow, because after they collide, then the tag move not running. So this is where error it start to move again. So this one is called, we can call this one as initial velocity. Right? Initial velocity, which one? It is x, the initial velocity of x. Why x? Because y is not moving. Y is not moving. And then this y, it is here. Right? The trolley y, initial velocity is 0. Right? Initial velocity is 0, right? Right? Why is 0? Because it is stationary. Okay? So now I can calculate in PQ. PQ, what is the speed? Right? What is the velocity? Velocity is equals to, right, distance over the time. Right? Right? But anyhow, the time here you need to be very, very careful. It is not 0.02 because it is 100 Hertz. 50 Hertz baru 0.02. Right? So we go and find the frequency. Frequency it is 100 Hertz. So we just learned it. Frequency is equals to 1 over T. Right? Period. Right? 1 over T. 1 over period. So the frequency here will be 100 is equals to 1 over T. So T gonna be 0.01 second. Alright, you go and divide it, you will get 0.01 second. So the velocity here, I don't know. Velocity is for PQ, it is distance. Distance is 10 cm over the time. Time, how long it take? You see here, how long time it take? It take here 1 tick, 2 tick, 3 tick, and 4 tick. 4 tick. 4 tick, it is 4 times 0.04. 0.01, what am I saying? Right? So it time 4 times 0.01 second. So what is the acceleration? They asked me about the ratio, so we do the ratio later. So the velocity is for 10 divided by 0.04. I will get it as 250. I will get 250 cms minus 1. Right, this is the velocity at here, 250. In cm, I lazy to that one, I just minus 1. Right, velocity here, 0. Right, so this is after collision. What is the velocity here? The velocity after the collision. Right, same thing, we are going to calculate at RS. RS, the velocity will be equivalent to distance over time. I use over like that, faster. Right, velocity is equals to distance, it is 5 cm. Over the time taken, it is 1, 2, 3, 4. 1 tick, it is 0.01. So it is 4 times 0.01. So how much should I get? 5 divided by 0.04. 5 divided by 0.04. I get 125. Velocity is 125. Right? So I get the velocity here, it is 125. So we know that elastic collision, this is inelastic collision because they stick together. So M1 U1 plus M2 U2 is equals to M1 plus M2 and then V. Alright, M1 don't know, U1 250, M1 250, M2 it is 0. 0 times whatever it is 0. 0 times whatever 0, don't care. Right? So M1 plus M2, I don't know. M1 plus M2 and then V. V is 125. So 250 M1 is equal to M1 plus M2, 125. That's all I can get. That's all I can get. So they want ratio, right? Ratio of mass 1 to M2. Oh, this one. 250 M1 is equals to 125 is equals to 125 M1 plus M2. So I move this one down, M1 over M1 plus M2 is equals to 125 over 250. 125 over 150. I want the ratio of mass M1 to M2. Cannot, no? Eh? Wait. So long not doing maths. My maths baccarat already. Right? 1 plus 125 M2. Why? Right? 250 minus 125. 125 M1 down. This one go down. It's 125, they are 125. So M1 to Is that okay for you? Any question? Is there any other question that you want to ask me? At 9:30 already. Now, if you like, click the like button or your friend tuition, right? Next year, I am giving free tuition on, not biology, my wife lah. Physics me until March, and then March only, the fees is 49 ringgit and 90 cent only, very very cheap, right? Compared to your tuition, right? You go, it is very very cheap, right? Feel free to ask your friend to that one. If you need any help, you can ask me anytime. I can help you. I will help you, right? Help me to like my channel, help me to share my channel. Thank you. Any other question before I end the class? Any question before I end the class? Alright, if no, then I'm gonna stop here. I will see you next lesson. Alright, thank you for the lesson. Alright, see you.